Hey everyone, nice to see you guys all in here. So, for this week's class, we're going to be talking about science more generally. And we are going to define the concept of science. We're going to learn a little bit about the history of science in the Western world. So, I'm putting that in the chat. We will also identify the assumptions behind science. So, last class, we started discussing some of the assumptions behind science. We discussed the assumption that scientists have to make in order to do science in the first place, which is that we live in an orderly and predictable universe. Remember, this is the assumptions scientists make to kind of get around Hume's problem of induction. Another assumption behind science that we discussed with regards to competing hypotheses is the simplicity assumption. So scientists assume that when you have two hypotheses that are supported by the same amount of evidence, you should go with the simpler one because it makes less assumptions that require justification. We'll talk now a little bit about other assumptions scientists make, and these assumptions are necessary to kind of get science up and running as a method of inquiry or as a method of obtaining knowledge about the world. We'll also consider some of the limitations of science. So, the types of things that science is not in the business of proving or cannot possibly prove. We'll consider the four relationships between science and religion. So there are four exhaustive relationships between science and religion. When I say exhaustive, I mean that logically these are the only four possible positions a person can take. So you can look at these four positions and then you can kind of decide for yourself which position you kind of agree with the most. Then we'll talk about just the scientific method itself. So science is relatively new. When we look at the history of, um, you know, of human beings, at least in the Western world, the concept of science, even the word science, did not get discovered or wasn't introduced into the lexicon until the 17th century. So during the scientific revolution. And it's during this time we get people actually kind of mapping out this method that we still use today across all the sciences, whether you're a psychologist or a biologist or a chemist or a physicist, you use the same method. So we'll talk about this method and how it was discovered. And then finally, we'll talk about the various strategies scientists use to distinguish between good and bad hypotheses or good science versus junk or pseudoscience. And simplicity was one value we just saw last class that scientists use to pick one hypothesis as better over another. Okay, so this is what we'll be doing this week. I'm hoping you guys are working on your writing assignments. I want you guys to remember for the writing assignments, you must refer to the text. So you're not going to get full points unless you engage with the books on Canvas that I've given you, because the whole point is not for you to just get the answers off the internet, but to actually read the text and engage with it. So always keep that in mind for the writing assignments. Now, let's get started. So, of course, we can ask ourselves this question like, what is science? How do we define it? We use it all the time. It's, of course, what was needed to develop the type of technology we're so used to in our modern world. I wouldn't be able to record this video without science. You wouldn't be able to watch it. We wouldn't be able to put a person on the moon. So what is this method of inquiry called science that has been so successful in these past, hundreds of years? Well, here's one way of defining what science is. It's a method of inquiry where we reason from observable facts to testable explanations for those facts. Now, what is meant by that is we look at the world and we notice some observable fact. When we notice some observable fact, usually it's going to take the form of like the reasoning process of induction. We notice some pattern in the world. We're noticing something happening in a systematic way. And we want to know why. And we want to know how. How is this happening? Why is this happening? And when we come up with explanations, the explanations that answer these why and how questions, we have now developed a hypothesis or like a theory about what we're observing. So to make this a little bit more simple, think of an example. Here's something we've been noticing a pattern in the actual world. The bee population has been declining since 2016. Okay. Now, this is something scientists have tracked over the course of now these past 9 years. And the question is why? Why is the bee population? What accounts for this pattern that I've noticed each year the bee population is declining? Well, perhaps it's because of the use of certain pesticides, the widespread use of certain pesticides. It could be because of the use of certain chemicals or toxins, et cetera, et cetera. This aspect where I'm answering this why or how question, that is akin to coming up with a hypothesis. And then I'll test that hypothesis. And now notice we're mimicking this process that we all are so used to called science. So science, you can think of it as like this thing that we do. It's this activity. It's this method of getting at facts about the world. It concerns the discovery, the observation, and the collection of facts in a systematic way and explains the relationship among these facts. We also use the word science as a noun to just refer to a body of knowledge sometimes, right? So we're like science, that's biology, chemistry, psychology, physics. So sometimes we use it in that way too. But the essence of what science is this method of inquiry. It's this method that we practice to get at facts about the world. Now, for every philosopher of science, including myself, part of our training is to be historians of science. So we look at the history of different sciences, whether it be chemistry or physics or psychology or biology. And the reason why we look at the history of science is because by looking at the history, it helps us understand how we came to the certain scientific theories today that we all tend to believe. So how do we come to Darwin's theory of evolution? Later in this class, we'll address how do we come to agree with Einstein's theory of relativity in physics? How did that happen? How do scientific revolutions work? And so thinking deeply about the history of science, it helps us better understand the methods of science and how to actually refine and get better as a scientific community. So here now will be a little crash course on the history of science, at least in the Western world. Okay? The history of science in general. So the scientific revolution. The scientific revolution. Okay. Okay. So in the Western world, the word science is actually quite new. So it wasn't until the scientific revolution around the 17th century that we even come up with the word. We even add this word to the human dictionary or the lexicon called science. Prior to that, people who were interested in explaining things about the natural world, so our physical world, the world of nature, they were called natural philosophers. So it wasn't until the scientific revolution that we even get the word science in the Western world. Now, here's a question for you. prior to the scientific revolution, what institution do you think was responsible for disseminating knowledge to the people of the West? How did people in the Western world obtain knowledge prior to the advent of science? You might be wondering, well, what institution? Well, prior to the advent of science, the institution that was supposedly the provider or the source of all truth and all knowledge in the Western world was the Catholic Church. So, and where does the Catholic Church get its information from? Well, from religious texts like the Bible. So prior to the scientific revolution, the idea is that everything we have come to know in the Western world comes just from the Bible and the Catholic Church's kind of interpretation of the Bible. And so that was the final source of knowledge prior to the scientific revolution. So everyday people like me and you, we would look to the Pope and church leaders to tell us what's what about the world. Now, the scientific revolution, therefore, challenges the epistemic or knowledge-based authority of the Catholic Church. And it has some key figures. Now, one key figure in the scientific revolution of the Western world is Nicholas Copernicus. Nicholas Copernicus. And he lived from 1473 to 15. Okay, so Nicholas Copernicus. He's very important for the scientific revolution. Now, what is Copernicus responsible for? He's responsible for advocating what is called the heliocentric model of planetary orbits. So now I'm going to erase some of this. Now, the heliocentric model of planetary orbits is the model that actually we believe today, which is just the sun is the center of our solar system, right? And all the planets in these ellipses revolve around the sun, okay? Prior to Copernicus, and later Kepler and Galileo, the church, the Catholic Church, defended what is called the geocentric model. The geocentric model of planetary orbits, where it was thought that the Earth is the center of not only our solar system, but of the universe. So the Earth. And all the planets and the sun itself, et cetera, revolve around the Earth. Okay? That was the geocentric model. Now, the geocentric model was the model endorsed by the Catholic Church. And it was very important to the Catholic Church that the Earth be the center not only of our solar system, but of the universe. And now you can kind of ask yourself, why? Why was the church so kind of hung up on this idea that the Earth must be the center of everything in our universe? And if you know a little bit about Christianity, what you'll know is the idea is us human beings, we're supposed to be the pinnacle of God's creation. And so how would it make any sense if we're the most important creatures, God creates? How could it possibly make sense that we're not the center of this universe, let alone solar system? Like, shouldn't we be the center of everything? If we're not the center of everything, how does it make sense that we're the most important or prized creatures in the whole universe? So the Catholic Church, really thinks that the Earth is the center of the solar system and universe, and the heliocentric model, kind of defended by Copernicus, is this new idea that we also have come to verify is true, that the sun is the center of our solar system. Now, let me just explain a little bit about what's going on here. Um, one thing to notice is that, or one thing let me first just say straight out, is that the geocentric model, it wasn't all that bad. And let me explain why. Like on scientific grounds, it wasn't all that bad. And the reason why I say this is because the same predictions the heliocentric model would make concerning when and where you would see a certain planet in the sky, the geocentric model would make that same prediction, right? So let's say the heliocentric model says, I don't know, Venus is going to be in this corner over here in the night sky. The geocentric model would similarly predict like that Venus would be in that same corner. So they were making the same empirical predictions, meaning like the same, they were being confirmed by the same evidence where we see the planets in the night sky. But now, based on our lecture last class, why might you think Copernicus likes the heliocentric model better than the geocentric? Now, let me make this clear. I'm going to send a video to show you this because it's kind of hard to explain. But on the geocentric model, as you're noticing, the way the planets revolve and the sun revolve around Earth is in these curlicues. So really it's going like this, like it's moving forward and then going in a mini circle and then moving forward again and then another mini circle. So hopefully you're noticing those curlicues. The reason why I drew up these curlicues is because on the geocentric model there was a puzzle, okay? If Earth is the center of our solar system, then it would appear like certain planets like Venus in the night sky move forward, backward, and then forward again. That would be like the trajectory. So here it would be like Venus is moving, hopefully you guys could see, like forward through the curlicue, then backwards through the curlicue, and then forward again. That's what we would observe, assuming Earth is the center. Okay? But once we kind of add in these curlicues, as I'm mentioning, these two models make the same predictions and are supported by the same evidence. So why might Copernicus like the heliocentric model better? Well, let's think back to last class. Which one is simpler? Which view of planetary orbits is simpler? And I hope you're all thinking the heliocentric. It's simpler because planets don't now revolve in these weird curlicues. That's called retrograde motion, and I'm going to send a video on that. Instead, planets revolve around the sun in perfect ellipses. So Copernicus advocated for the heliocentric model because of its simplicity. It's like mathematical or geometrical simplicity and elegance. And as we're noticing, that's a big value, not of just scientists, but of mathematicians too. Like the simpler solution seems more likely to be true. Okay. Now, I want to make this crystal clear. In the Western world, we do say Copernicus is responsible for the heliocentric model, though he is not the one who first discovers it. In fact, he was greatly influenced by the Islamic philosophers during the Islamic Golden Age. So, during kind of the Crusades, there was a time in the Western world, and especially in areas that were Christian, where there was a lot of burning of old books and materials from philosophers like the ancient Greeks and ancient mathematicians. And it was during this time that Islamic philosophers saved the works of people like Aristotle and Plato and et cetera, et cetera. And so they, of course, were interested as well in how the planets orbit or how the planets move in the night sky. And so al-Battani, a famous Islamic mathematician, kind of comes up with this heliocentric model, and he's influenced by even older, people way further back in human history, like the ancient Greeks, etc. So this idea is not just Copernicus's idea. He kind of gets inspiration from these other thinkers, but he's like the big advocate in the Western world for this view that the sun is the center of the planetary orbits. Okay. Now, why is Copernicus so important? I mean, if he himself is not the one who comes up with this just on his own, why do we find him so important in the Western world, especially with regards to generating or starting the scientific revolution? Well, notice that by supporting the heliocentric model over the geocentric, Copernicus is really saying that, look, the Catholic Church, you're wrong. You're not correct about this. The Earth is not the center of the solar system. It doesn't make sense. Like, you can even think of it, you can even invoke God here. Like, why would God make such a clunky, weird universe where planets go back and forth as they orbit around things? Wouldn't it just make some more sense, because this is simpler, that planets orbit around the sun in just these nice ellipses? Or he thought there were circles. Later, Kepler is the one who says they're like ellipses. So now notice what Copernicus is really doing is he's challenging the authority of the Catholic Church, and that is a really big deal, right? No one does that during that time. And so for this reason, he's very important and is thought to have been a key figure in launching the scientific revolution, because he challenges the authority of the Catholic Church, and he proposes, right, that this other method of inquiry, namely science, where we observe things and we test those observations, that method is somehow better or just as good as, or can compete with the knowledge coming from the church. And so this is why he's really important in the history of Western thought and Western science. He really goes against the Catholic Church, and he's now proposing this new method of getting facts about the world that isn't just the Catholic Church. A little fast forward. So for a long time, people were not convinced by Copernicus. He gets into a lot of trouble. Later, Galileo very famously comes on the scene, and he's the one who helps kind of invent the modern day telescope. And it's through that invention that we actually observe, like, firsthand empirical observation. We're like actually seeing with our own eyes that the planets do move around the sun in this elliptical way, and they don't move around Earth in this weird curly Q way. We like directly observe it with a telescope. And once we get that direct observation from Galileo, I'll write his name down, through the advent of the telescope, then people are convinced that yes, okay, this is how the planets orbit and not this, and that the church was wrong, and this method called science was correct. And so this launches the scientific revolution. An even bigger key figure in the scientific revolution, and I'm going to write this, is this man, Sir Francis Bacon. Okay. So Sir Francis Bacon, he lived from 1561 to 1626. And he is very famous for writing this book called Novum Organum. And he writes this book in 1620. Okay. Now, the reason why this book is so important. And the reason why actually a lot of historians really consider Bacon the father of modern science, or the father or the generator of the scientific revolution in the Western world, is because in this book, Novum Organum, he really, uh, in detail, discusses what we now call the scientific method. So here he really like discusses and discovers what we now call the scientific method. So he discovers the scientific method. He writes about it in this book. He writes the steps. He discusses how scientists should be very skeptical towards their own findings. They should constantly be testing and retesting their findings. And so, therefore, most generally, he claims that we can discover truths about the world through just observation and experimentation. And this is, of course, a big, big deal, because this now is like illustrating to us, no, okay, we don't just have to go to religious texts to learn about things. We can actually learn about things on our own as individuals, so long as we follow these proper methods of observation and experimentation. So in this book, he really sets out quite neatly and clearly the scientific method that we still use today, which is quite interesting. Okay. So science now is this knowledge producing enterprise, and it's finally being established in the Western world in the 17th century. And also, we are starting to see that, like any kind of domain of inquiry where we're like observing things and getting at facts about the world through observation and through these steps called the scientific method, we're now calling it this word science. Before, we didn't even have a word for it. So the two big key players, once again, is Sir Francis Bacon as well as Copernicus. Now I'm going to stop it for now. That'll be a little bit about the history. I'm going to send you a video that shows you the comparison between the geocentric versus heliocentric models of planetary orbits. And that will be it for a little bit of the crash course history and the history of like the scientific revolution. Then we'll talk more about the assumptions behind science. So I'm going to end the stream for now. Thank you.